scheme of things, the key points that to realize is you will be a nice sea front in this side of the um, building. So this north. So for an example, this phase of the entire structure is having very good views in that direction directly and that way. So and then each of these units will have a very good view towards C. In some cases, particularly in units B and unit C, will have two angles, whereas most likely unit A and D, in your case D, will be having one directional angle to see the C view. So that is one of the things which we need to identify. One other interesting and important factor of your interior design perspective is to see the directions. Just give me a second. System does not work a little. Okay. So the direction of north, east, south, and west is important in your what we call the passive design principles. So I'm pretty sure you are taking these things into consideration as you're progressing. You're trying to capture the best part of the views as best as you can, and you're locating your rooms and identifying this be the case. One of the things which I like to emphasize at the beginning, the size of these residences were fairly large compared to typical Hong Kong apartments. So you will be probably a little bit surprised with the dimensions and things like that. If that is the case, you can even imagine that you will be designing this something for an Australian situation. These are typical, very good standards of here. And I know this particular drawing was taken from Hong Kong. I think quite some time ago. They started teaching this in 2006 or 2008, I remember. So this was one of the projects going on at the time. So obviously you would most of the, particularly the two units that I am discussing here, one is C, which will be having a direct view. Not only that, but that is the east of the location. The north is covered pretty much by the adjoining units, but most of your interior design would take into consideration east and the southeast aspect of the block. Whereas if we are looking at the same for unit D category, you will be looking at, if I color it in a different color, so you will be overall sense you are looking at a passage like that. So from east, you will be having an exposure to east, or rather northeast. It's not bad, it's really good. And then you will be having southwest orientation in part of your type D, unit type D situation. But on the north side, direct north side, your views you are in a very cool system where you are behind unit C, so there's no much outside exposure to your unit. So when you're planning inside your unit D, so you are aware of these situations, and then proceed with that. So that is the idea. We will discuss how smart your work. Unfortunately, had I been in Hong Kong, I would be sitting down with you and then drawing on your uh, making some comments on your drawings and then giving a feedback kind of thing. Unfortunately, we do not have that situation in this situation, but we will try and do our best. Uh, at the moment. Okay. Um, all right. So overall scheme of things is you have to, in this situation, take into consideration the northern aspect. Northeast is normally good. Southwest is particularly west side of your building is a little bit warmer. So west side, 2 units, you are particularly unit D has a little bit of west aspect of it. Unit C is a northern aspect is there, and then of course to the other side is south and southwest and southeast orientation of unit D. So with that in mind, I think we will proceed the a little bit of greater exposure now. So in a broader sense, both units have their advantages and some limitations. So I again, if I use the enlarged version of it, what I have done there with red color, which I have highlighted this from here. Obviously, the couple of things to be important things you can visualize here is where your entrance is to your house, and then you will be having a particular uh, aspect which you can maximize. You will be having a service duct here and service duct there. So unit C is a little bit fortunate in planning perspective because you will be having access to service ducts. Whereas when you look at unit A, unit D, you will be having slightly different setting as we discussed. The most important thing in your case, you're a little bit restricted from the services as you have only one service area, service duct area, which you have to feed into. So that is slightly a minor complexity here. But having said that, you should be able to get it right. But on the other hand, your structure is a very a much relatively larger area, and then you have the advantages due to that. So that's the situation, guys. And of course, as we said about Unit C, Unit D will have the north aspect is pretty much covered by the other surrounding building. You are more exposed in the north-south, northwest direction, and then also south east direction. You're exposed, but you're a little bit covered by the other area. So these are important things when you are looking at your interior design, particularly the passive design principles aspect. Let's first do the interior design part, and then we will come to the floor framing and then slab and beam design. Probably you are currently there, but you can actually review when I start talking about how you can incorporate some of the passive design principles and other bright ideas. I'm pretty sure your allocation, we are involving about 1, 2, 3, 4, 5, 30 to 38, 8 floors. And then everyone has probably selected your your design type and then ready to go. I will, in this particular case, let's have a quick look at how, if in my situation, how I would look this in a design perspective. I will be revisiting this picture, but I wanted you to visualize in this one. Sorry, this is not yours. You had to go to number C. Um, sorry, number D. So you can, it is a very similar one to the previous one. So this is what your apartment is. So you can visualize where your entrance points and other things you must have put your interior layout. But let's talk a little bit about the interior layout in a passive design principles perspective, and also what we call the topological arrangement interior design aspect. So I'll take you to this particular slide. We will revisit the plans. So I will sketch and then show things as I go. One of the things which you need to probably will be struggling with a little bit because of the size of this particular footprint of the building, particularly your unit area, you need to identify how you utilize it in a in an architectural sense to get the best outcome, which is what we call the topological considerations. Now, if I am designing, if I am doing this particular assignment, one of the first things I see is, even though if a house is very small or big, normally the spaces available within a residential building can be brought into three different categories. What I would be saying by these words, living spaces. Living spaces here mainly refers to the daytime spaces that you utilize during the day, during daytime. So living spaces can also be in a apartment of this size, will be also seen as in two different angles: formal living and family living. What is formal living? Formal living is that when a set of visitors come to your place, and then when the family is inside the house, the family should not be felt like, if say for an example, your mother's father's friends come, and then you should not feel like your movements are a little bit restricted in that situation. At the same time, family should have freedom to move while some visitors around the place as well. So in large modern um, house and apartment designs, you will find that these two areas try to be slightly treated in a different way. So at the moment, keep that in mind as family living and formal living. Formal living area is that you can have a formal lounge area in a house that is mainly at the main entrance. And then you will try to put the kitchen a little bit further away. But I know in your day-to-day apartments that you are using, it may be not the case, because for two reasons. One thing is, some of these apartments would have been fairly old-fashioned, designed long time ago. The second aspect of it is because of the restricted areas involved in, especially Hong Kong, and even where I originally came from, Sri Lanka and India, those type of settings. But if you're looking at a modern, high-end design, that you will agree with me, there will be spaces. So what we wanted to do is to give you a large enough area so that you can actually exercise these things in better. So living can be subdivided into formal living and family. Family living areas can be a little bit messier. You feel you move in and around freely. It is not well kept. Whereas the formal areas would be kept very clean and tidy and nice, because visitors come, that is where they will be they'll be sitting. The last thing you want is the visitors to walk around all the through the house, including your family areas, and getting into their formal sitting area. If that is the case, that design does not make sense. The other thing, other space allocation is, I like to see it as resting spaces, which is what you use in the most at the night time. So where would you actually position these things in the best cool climate condition or best hot climate situation within your house? How would you try and do these resting areas? Resting areas is basically bedrooms. So of course you have enough space to put a master bedroom and a couple of additional bedrooms because the size of the footprint that we have given you. So bedrooms, reading rooms, study rooms can be considered as resting rooms, and then try to make it quieter and a little bit away from hassle and bustle. So that is where the resting rooms are concerned. Utilities areas. Now, what are utilities areas in a situation? Of course, in Australian conditions, utilities areas is that we will be, most houses will be having a double car garage attached to the house, unlike in Hong Kong. But in Hong Kong situation, of course, utilities areas can be considered as a storage areas, kitchen area, a laundry area can be fall into utilities areas. So very boring, restricted aspect can be like storages and laundry, cloth lining, and all that sort of stuff can be located in utilities area. However, nowadays the kitchen is becoming a major attractive point in a household, and then therefore the kitchen can be is a utility area, but has to be properly positioned if the family living and formal living. So basically, fundamentally, what we are saying is, guys, all we can draw some straight lines and then identify rooms and then do it. That's not what we are after. This assignment, that you have some sort of interpretation and understanding of the modern housing, and as well as you identify these living spaces, resting spaces, and utility spaces, and how they are interrelated. This is what we call the topological consideration. Okay, topology is defined by the way in which constituent parts, which means in this case living, resting, and utilities constituent parts, are interrelated or arranged. Orientation and relative positioning of interior spaces improves occupants' livability and home functionality. What it does is, if you get your topological considerations right, you can create with the same space a quiet environment, privacy, and then you can have a livability can be improved, home functionality is better. So if you wanted to go in and out of the house, and then you can kind of do it in a way the others are not getting affected, and things like that. But I know most departments you may be used to may not have that comfort, but just imagine that overall scheme of things in future sense as well. Of course, we all like to have best sceneries and aesthetic interior and exterior aesthetic requirements, and the beauty of the house, scenery around the house, and all that sort of stuff. I'm pretty sure majority of you, when you're thinking about this project, you have immediately gone and tried to select probably the east-facing blocks. East facing houses, because the scenic aspect of it. Scenic aspect is one thing, and also from a passive design consideration point of view, the important about passive design is that you have your thermal comfort inside the house. Is you can get the best outcome inside the house, considering your orientation. How can you do it? It is not always the best orientation you may get, but what can we make the best out of it is the situation. So passive design considerations are mainly talking about energy, as you know, energy saving, but more so than energy saving, it is also referring to comfortable living and also get the best thermal comfort inside the house. Okay, so that is a basic idea of that. Privacy and entertainment aspect you must have considered. I know you have enough space to put, say, gym or a reading room, or a kind of space in this house. You have enough. I said creating quiet environment within the house, which means what we call the acoustic quality within the house, which means if you are speaking and that acoustic, that the noise does not spread. So there are measures, there are ways of doing those things. In minimum intrusion of noise is an important thing, both external and interior noise. So most of the housing, one of the major factors that is considering is that the stress levels of occupants of houses with the greater noise is always an issue. Particularly external noise such as traffic noise, so air traffic, say road traffic noise, construction noise, and things like that. So inside the house, the acoustic quality inside the house is an important aspect as well. So there are a lot of things actually home designers normally discuss. Um, Personal preferences and needs, of course, there you have designed this house the way that you want. By this time you must have, majority of y'all have had the plan done, so I'm not asking you to change it, but what I'm asking you is that whatever you have given there, when you're submitting, that make sure one of the best ways to do is you get the plan and then put some arrows into room areas and explain in a cloud kind of a setting, a little description why you have pushed that particular area, for what reason, how did you do that, and in that way you can maximize your marks, because this is a thing. See, okay, there is a rationale between what this particular student is doing. That is where actually your marks will be maximized interior layout design wise. Otherwise, if your rooms and other things are in wrong places, then it's unfortunately that is not the way. That doesn't mean a design. So you have to prove that you have actually thought deeply about this design task. Okay. Selecting color schemes, I will leave that those are features, general architectural features inside the houses. You may some of the words even will be really new to you. For an example, cornices, architraves, skirtings. Nowadays, where the color selection inside the house is a pretty interesting exercise, because you have a lot of options in colors as well. So if you take this to the next level, it is a really interesting area to study. After all, at the end of the day, if you can get some knowledge into get when you're buying a house, or when you're renting a house, or when you're arranging a house, that would be very useful, isn't it? The other thing which I wanted to give, I think probably I'm not sure that these rough dimensions were given by our colleagues who are teaching you, your lecturers there, and also probably used by the past students anyway. The formal and lounge and dining, you will be looking at about in meters. These values are given in meters, by the way. 3.5 meters to about 5. These are standard values used in Australia. And then you can utilize this kind of spacing in the houses given to you, house plans given to you. But I am 100% aware that not in Hong Kong situations, most of these dimensions are out of it is not real. It is completely, I mean, you will be very the apartments in high density living. High density living can be comfortable, mind you, but high density living it doesn't have these spaces. But in this that is why I have provided this anyway. make sure that some other things which you can accommodate. One of the major areas is, for an example, uh, the corridor area, for an example, the corridor width. So it is about 1.2 meters is a decent corridor width if you wanted to see corridors between the rooms. If you haven't thought about it. Now you may ask someone, where does this 1.2 meter comes from? In fact, 1.2 meter comes from the fact that it's a movement of the furniture and things like that, especially if it is an couple of levels, two-story building kind of thing. But it is 1.2 you can use between your bedrooms and other rooms. Kitchens are normally nowadays longer. The modern design are longer, but I have suggested 3 by 3 meters should be good enough to secure a good a kitchen setting. So these values are not constants or essential, but it gives you a rough idea of what sort of room sizes you can use in the space of the house, overall house that we have given to you, house plan given to you. Okay, there are two important aspects of I wanted to emphasize here. We are also looking at what the passive design principles you're using in your interior design. That's one of the major things to do. So, for an example, in a quick way, if I am to explain the passive design principles compared to Hong Kong versus Melbourne, say for an example, fundamental difference is Melbourne in Australia, where I am living. Now we are in the winter, so it's very cold. You can see that I'm having a very thick flannel jacket here to keep me warm. So the Melbourne conditions are normally classified in weather-wise as arid, cooler climate. Arid means here the air is dry. The relative humidity is very, very low, in 40%, 30%, that sort of thing, so that we are not sweating at any time. So that is what we call the arid and cooler climates. However, even within Australia, because Australia is a very large continent, if we take a car and then go about 900 kilometers northwards towards Sydney and Brisbane, about 1,200 kilometers, and then I'll be ended up in a weather condition very similar to Hong Kong condition. That is, we name as warm and humid climatic condition. Humid means we will be talking 80 to 90%, even some cases in the country which I originally came from, Sri Lanka. Most of the time we have about some seasons we have about 95% humidity. What does that really mean? Air is fully saturated with vapor, and our perspirations, it has no way of going to air. Air is saturated with moisture, so we start to sweat in no time. Okay, so that is what is happening. So relative humidity is one of the major issues. It is very low here, very high in your part of the world. So that is when you wanted to have that situation, cooling systems are slightly different what you are using. For an example, evaporative cooling systems are effective in arid climates where I just explained as Melbourne, but it is not very effective in Brisbane or Sydney, or to that matter, Hong Kong. But you have to find a different systems. If you ask me, I would say the most effective thing in your design in Hong Kong conditions is try and achieve this particular point 5. What does that says? Creating natural cross flow ventilation cycles in the most effective way of doing that in your country. The designer's ability to encourage such passive cross flow ventilation cycles energy efficient and desirable. Strategic position and alignment of external windows, internal openings ensure indoor temperature remains lower during night times is the key to the matter. Say in warmer uh, and humid conditions, what happens is uh, the temperature difference between day and night are very small, up to about 2 degrees to 5 degrees. But in a arid, cooler climates, it is different. Arid, cooler climate, the temperature difference can be about 10 or 15 at night, and that's fine. That's ideal for sleeping, but it is not in your situation. So therefore, if you have about 4 or 5 people inside a house, that even the temperature can go up by about 2 degrees extra. Within the room, if you have 2 people, it can go about 5 degrees extra. So you can see that it is one of the major important things is to have the cross ventilation going. Of course, the other quicker and easier method is to go for air conditioning, which is most of almost all the houses from having. I remember in Hong Kong residential buildings. But the problem there is that there's a large proportion of energy has been used, and then as a consequence, that is considered as not very sustainable practice. But having said that, Hong Kong has gone a long way. I know that yesterday there was a question. I was aware of that project, but not the details. But one of the provinces actually used cooling air using seawater and then pumping that cooled air back into residential housing. That's fantastic system, but I'm not sure how energy efficient that was. So we have to take into account and then say that is fantastic idea compared to air conditioning. It may be slightly better, but how much would it require energy to cool the temperature of the seawater? It is relatively cooler, definitely at least about 5 to 6 degrees cooler in the mid range. So that is definitely a plus. But if it is not consuming too much energy, then it will be a good solution. There's another very important point I'll discuss about the creating natural cross flow. How can we do that? It is called chimney effect, which means there's a principle which we both know. Warmer air rises up, colder air stays at low. If you have a room, if you heat the air, the hot air will be risen towards the ceiling, and then the colder air will be at the lower half of the room. If we are smart enough, if we have an outlet for the hotter air, which is located at high up, closer to the ceiling, and then if we have an inlet closer to the floor, and there is a chance that cooler every time the hot air escapes through the upper opening, in this case lowers, and there's a draft can be created where the cool air will be sucked into that room. So this is called the cross ventilation. You can do cross ventilation for an entire house or a room. And also, while doing that, if your house is large, you can direct that air in strategic way, creating openings and openings at various heights and things like that, so that it flushes off and it goes through the interior passages, including the corridors and other rooms and things like that. If you redirect this flow, and then that can be very efficient. But it is easy to say than done. It is not always feasible, but it is something that you can try and show that you have actually adopted that system. So let's go to the next item that is important is the So this particular item number 10, you can see that, yeah, it can be, so the north and south walls should be as open as possible to allow for cross ventilation, considering wind directions. This requires that the plan agreement should avoid double blanking rooms. Uh, so if you were to select the other most important thing in terms of cross ventilation, and then this would be a nice point to try and achieve. Um, so double blanked rooms also means you try to open position doors even when the draft is created. The when it comes through the main door, say for an example, and it can be going through another door of another room and then get its path. So you have to strategically create the openings either through doors or windows to make sure that it works well. So this principle is relatively simpler to it is not ideal, but simply able to do by selecting uh, warmer side will have louvers above, and then shorter, colder side will have the louvers at below the windows and openings below the windows. And then these louvers can be adjusted as completely closed and open as well. So these are very modern window furniture is coming through as we speak. So it is in a broader sense, that is where how you demonstrate your passive design principles per se. Um, I think this is obvious. I have, I think, shown some other things. Normally, architects use bubble diagrams to understand the functionality, efficiency, and creating pleasant living spaces by without not putting in rectangular form, rather bubbles, and then push around these bubbles, and then create an idea in their head, so that these corridors and other things starting to form even inside a room or an entire building. So that is not our strength. We engineers are not doing that. I'm not expected to do that anyway. But I want you guys to have a feel for it. It can be helpful if your mind is right, and if you're not working in a rigid rectangular shape, and then you try to fit in those in lines, but you can get your ideas flowing if you see it in open-ended way. So architects are doing that. In structural, the engineering aspect, that is the architectural aspect of this task. Engineering aspect, of course, is structural framing, which we'll be discussing later in the presentation, and we'll discuss it effectively. I think yesterday we have just shown it just to say two things. Normally, the architects or even engineers, good engineers, what they do is they take a sort of a checkered squared paper, which you will be having your scale, the feeling of scale. Say, for an example, each one of these little squares reflecting 1 meter, and then you will roughly can have your thoughts process going. And that's one thing, and also most architects, they draw to scale, and then you overlay, you draw it in butter paper or tracing paper, and then you overlay on the previous one, and then trace it again, and then improve things. That is how they do it. It's a fun activity. If you're really good at it, and you become a very good designer. And then we go and cover things up with the columns or the beams and whatever. Here, I don't think columns required, because all the shear walls are there for all the gravity loads to be supported. So columns are not needed, additional columns are not needed, but we require beams and slabs, of course. And that is what I call the flow framing. So that's a flow framing aspect which requires you to cover. Okay, now, that take us to closer to 1 hour of a chat. But we will discuss uh, design for design for deconstruction philosophy. That is one of the things which you have covered in the mid semester or assignment one. But that part is important to bring it into this one in a structural sense. Now, you may have seen design for deconstruction. Now, philosophically, we discussed yesterday's lecture what is DFD is. So there are two DFDs we are talking. It is a little bit confusing. Design for demolition is one thing. Design for reconstruction is another thing. So design for demolition here, which most of the buildings are doing in the past practices, even today, is to completely demolish it, crush it, and then go and dump it on a landfill, what we call landfill. So the material are not separated or otherwise. Now, in the sustainable aspect, most of the countries take this seriously. Now they have regulation. Hang on a second, you can have this demolition, but you can't dump everything in one place. You need to have separate identify which material goes where. So design for deconstruction here means you can use part of this design. So your reinforced concrete framework and slab, they are permanent structure. But define the interior walls can be made for design to be deconstruct. What does that really means? You can remove them, like for an example, in a car situation, you can, if you take the car to a wrecker, and what they will do is they will take the parts which they can reuse, and then the things which they can't reuse, they will uh, go and dump into the dumping yard. So that is the idea here. So we will try and see whether there are a lot of advantages happening. Long time ago, I think if you look at the traditional buildings few years back, most of this partition walls have been made out of either brickwork or blockwork. It is wet construction. Um, and there are two disadvantages I can see in that one. Of course, in sometimes non-load bearing walls are being done like that. So I can understand load bearing walls are done are like that, but non-load bearing walls, partition walls, doesn't have to be like that. One thing is that those walls weight very heavy. If you design a floor slab to sustain a block wall like that, you have to make sure there's a beam going under, or a design that you don't put those type of things right on slabs. You can do that, but at the same time, then you have to make sure that you design for that dead load, which is relatively heavy. So instead, over the last, I'm not saying when I say recent, it is last 30, 40 years, this practice has been slowly changed to what now we call the lightweight drywall construction. These are very simple, non-load bearing walls, but they are only partition walls. But they are very high good quality in partition, finishes, acoustic quality, all the other things are there except load bearing capacity. So what we are doing nowadays, most of the time, we try our level best to incorporate all the internal walls in dry, lightweight construction walls. But there is another advantage of these things. Speed of construction has increased enormously, and the other thing is the acoustic quality is you can improve. Fire resistivity you can improve quite effectively. So there are a lot of advantages. In this assignment, we like our students before graduation to understand this interior wall framing as a product. We are not asking you to design from scratch or do calculations for that, but we would like you to use that in a sensible way, and then also show us some details where these interior drywall panels or drywall frames can be reused. Therefore, can you design it in such a way that the panel system, your internal wall system, is done in such a way that is what the assessors are looking for, whether actually it can be disassembled and then uh, move into another place or given to a record or recycle yard or whatever it is. So, and there's another very important reason for that as well. Say, for an example, you design a residential, sorry, office tower. Let's say after 30 years or 20 years or whatever that is, and all of a sudden somebody acquired that particular property and they wanted to convert it to a residential apartment. Now, if you have drywall, interior drywall, non-load bearing wall, you can strip it very very quickly and then reuse it, isn't it? But if it is permanent, you have to demolish it, and then because what is the interior layout of office and interior layout of a house are totally different things, isn't it? It can happen other way around as well. It's a residential building. Somebody want to buy it and want to convert it to a hotel. Okay, if it was done all in brickwork and things like that, the demolition prob and reconstructees would be the best option. Alternatively, if we are really environmentally focused, we might consider this other way around, and they say, hang on a second, we can use drywalls, we can remove all these things, disassemble them, keep the structural frame as a skeleton, and then we can refurbish it to be a hotel, which is easy to do. So those are a lot of advantages in that system. So we want that little element. So we are now coming from the interior layout design aspect is being sort of you're exposed to interior wall system is more smart and more environmentally sustainable. Otherwise, they are going to be ended up in landfills, and entire demolition will be normally once it is demolished, it's all mixed and crumbled together. You can't easily separate them, and so there are a lot of advantages in the way that we are traveling towards the sustainability aspect of it. So here we don't expect you to design this at all, design calculations. What we want you to really study these manuals, and then I am giving here. There are hundreds and hundreds of drywall suppliers and manufacturers and in the world. So this is one of the companies which is popular in Australia and involved in a lot of interior layout planning and also interior drywall construction aspects. But what I have done here is, guys, you can see internal. You will be having in your design. You have to have the external walls also identified, um, and because they're other than the black lines that you see. You may require some external walls, and then you need some maybe sliding doors for the balconies, as shown in the mid picture. So external stud walls, these are called stud walls as well, and then the internal stud walls. And the other thing is, a lot of students I see in your assignments, you guys assume those black color walls are perfect lines. They are not that. They are concrete structural walls, unless of course you pay a huge amount. It will not be constructed to a precast quality, which is S3 quality of the surface. So for surface is very rugged. It is not smooth. You can't simply paint over it. In a house like that, you you have to identify a way of so there are interior walls can be coming from two ways. One thing is also freestanding interior partition walls, as well as if you have structural elements like columns or walls, it has to be covered nicely and it should look like the other part of the wall as well. So that is also coming as part of the requirement. Uh, in most of the designs I see, students do a straight line from the concrete wall to concrete wall, thinking that it is like a plastered, very smooth surface. No, it is not. It is rather can be covered by the stud walls or dry dry walls methods. So, and the other thing is the ceiling. Ceiling is also is what we normally call false ceiling. We don't go and paint in the soffit or the underside of the slabs. That is not what we do, because there will be lots of services like water supply, cooling ducts, electricity, water, sewer lines, pipes, all that will start to happen. Therefore, you will be having a ceiling. It is in the ceiling cavity, all these things are happening between the ceiling and the slab. So you have to nowadays the ceilings are also kind of dry construction, not no plastering in mall or anything like that. It can be very quickly erected, put it in place. So that part is also coming. So these manuals you can easily download from online. I will also provide it. It is just a set of details, more or less. You should know that how these drywalls can be connected to the soffit of your upper slab, and also has to be firmly supported on the floor slab of yours, otherwise it will fall. So that aspect will come into play in detail. We only want detailing here just to make sure that you are exposed to these type of products. There are plenty of Hong Kong related companies who are producing in Hong Kong and China. Obviously, you can use any stud wall or drywall system made available, but as long as you use proper guidance through one of their catalogs, how to install, how to design, what are the details look like, how do you connect it to the floor slab, how do you connect it to the underside of the slab before the ceiling goes in, and that sort of those type of detailing will be required. Now, before I go, I will have now we have almost gone 1.5 hours or so. What we will have about 20-minute break here for all of us, and then from Hong Kong time, I'll be seeing you around 3:50 maybe. Now what's the time there? 3:33, isn't it? 3:30. Yeah, we'll have 20 minutes, and 20-minute break. Okay, so I'll keep on recording. So when you're opening the recording, there will be 20-minute gap will come here, but at least you know that is meant to be like that. We can't switch off. Then we have to go to a different classroom to have another recording. It's a limitation of the Collaborate Ultra. So I will say basically, let me post a note saying so I'll be seeing you at 3:50. Yeah. Okay, everybody. So go to the second session, and then we should be able to finish within an hour or so. Um, Most likely 45 minutes would do. Um, okay, so now we are into the structural design and validation of the aspect. So that is the design aspect of your work, other than the interior design and things like that. So if we go to the flow, we will start a discussion. So we are looking at C and D. I will first start with probably unit D. Now, interesting aspects are you have to separate your external walls and internal walls, isn't it? So these are your, let's say, these are your external walls. Um, so the interior layout um, will determine. So all these are external walls, and then you will be having a kind of external wall here as well, of course, with an opening like a sliding door or whatever. So sorry, my line is not really right. So let's say this is a sliding door. Um, can you all hear me? Hello? Okay, great. So you have to identify in your house what are the external walls. So you have to, ideally, you should do elevation, which means you come to the side and have a look. And depending on flow to flow height, let's say for argument's sake, flow to flow height is 3.3 or 3.5 or whatever you are using. Uh, let's let's try and draw a typical flow flow to flow elevation, and then you will see that there are something very interesting there. um, so based on your based on your um, based on your interior layouts, of course, you will be having quite a number of interior walls here. They are, of course, as we said, dry wall construction. These outer walls also can be dry wall construction. So in this case, you will be having one interior walls, one exterior walls to look at. So you can draw a couple of elevations and then show. If I may say, yes, let's go and see a typical external wall, what it looks like. Then you will realize. So this is your. I go with a line. So this is basically what? Okay. Okay. Say this is a kind of a wall. This is the top of your flow slab, which is your flow finish flow level, and then there's another. This is the next level. Let's say this is nth level, and this is n+1 level. So now, if I say, okay, this is roughly whatever your flow height is. Let's assume that I'm talking about, say, 3.3 meter height or something like that. So this is 3.3 meter height. So we don't know what the slabs look like, or what's the depth of the slab, or so let's say in here we may have a kind of a slab, and maybe beams. We do not know the sizes of these beams, but we know the overall flow-to-flow height is that. And then, I mean, one beam may be that, and the other beam may be a little bit deeper. We don't know it. Um, so there are a few things. So this is the flow-to-flow height, and then there's something called clear height, or which means flow to ceiling, the height of. So we'll use a blue color line. Let's argument's sake that um, our ceiling is normally like that. So this is the ceiling line. So this is the ceiling line. So if you if you have 3.3 here, and then depending on the beam depth, will determine what is this height is, isn't it? Usually, ideally, we would like to have the highest ceiling height. It looks your room bigger, your living areas fairly relatively bigger. So the question mark is, what is this value? It depending on lots of things. If you wanted to have a really clear space and then as high as possible, you have to optimize this flow slab design as much as possible so the overall flow depth is good. And on top of that, you will be having another gap at least about 300 millimeters or so to ensure that any services are run. So that would determine what is this value is. So if we wanted to say this, I would say clear height maybe. Um, so it is equal to flow to flow height, which is 3 meters, 3.5 meters, I said, wasn't it? 3.5 meters. Take away what you call the structural depth. Structural depth here is the two red lines, which is the top of the slab, and also the deepest beam position or average beam position or something like that. Let's say we like to have it. We don't know because we have not designed. Therefore, most of the times that so I'll say structural depth. Whatever it is, we don't know because we haven't designed it as yet. And then also, let's say, allow for about 300 millimeters for services. So you can see that would determine what is the clear ceiling height. If I do an example here, so if I say clear ceiling height, clear height, I would say, right? You say in this particular case, I wanted to have I want to have a 2.7. 2.7 is a good uh, clear height architecturally. I like to have a 2.7 clear height. 2.1 is also okay. Not 2.1 is not okay. Actually, 2.7 to 3 would be nice, but then we will be having only 300 millimeters to work with. So let's say I go for a clear height of 2.7. 2.4 is also good, but 2.7 is fantastic. But let's say that 2.7. If that is the case, what will be your structural depth, overall structural depth plus the services? So you will have this is a requirement. You put it as a task for you to decide, and then what you can do is say, okay, in this case, I had to make sure my uh, what is happening here? Yeah. Oh. All right. Say 2.7, we said 3.5. So we will be having about 800 millimeter or 800 millimeter clear if 2.800 millimeter structural depth, overall depth. So this the structural depth plus 300 millimeters, isn't it? Um, we had that we said that we will keep about clear height of about 300, and then so you will be looking at uh, 800 millimeters kind of a depth overall. So you can see we have to maintain the overall structural depth, which is the slab and the beams, to be around 500 millimeters, which means uh, if you wanted to achieve that, which indicates, okay, so our structural depth should be limited to about 500-ish. Is that correct? I'll double check again. 800 millimeters. Yes, you had to do it within 500 millimeters. Now we don't know. We have not designed it as yet, but never mind. We set a task and then see where we ended up being. So that is the kind of feeling that you have to have. And the other thing is, if I ask you, oh, in your interior walls, this is the ceiling, of course. I will name that as ceiling. Ceiling is that one. So you can see we are sort of getting somewhere. And may I ask, anybody knows what sort of a height, normally a standard height of a door? Um, a typical door height will be about 2.1 meters. Standard height of a door is 2.1 meters. So you can see this is my door. Say for an example, I have a interior wall or whatever it is, a sliding door. So you can normally, this value is about, this is the door height. um, so that comes to about 2.1. So these elevations, you're drawing these things will actually help you to visualize what's going on here before you do your calculations and things like that. This is the real scenario. What does that really means is that you have a fair bit of, if this is a wall, if this is the wall that we are looking, I use a lighter color. So this is so this entire area is your your internal wall. Say for an example, or external wall, you would know that you'll be having this wall keeps going, isn't it? These walls are going up to the slab, um, uh, but we have to make sure that there are enough gaps. So if you have a situation uh, like that, you roughly know how much of space is. So if you have 3.5 meters and then 2.1 meters here, so you will be having 1.1 meters of a wall section above. So a lot of students forget that for some reason. So this is the door. Um, Okay, so this is a door. This is a typical section through your structure. That is what a lot of students don't really do. Your elevations. You are looking at the plan, so it is hard for you to really understand what's going on. So this is the other slab, and then don't know, maybe it has a slightly different setting or the same setting. So you can see that in this situation, So this is the lower level. So that is how this elevation is very important for you to know. You now know, okay, you have to work within 500 millimeters of it. Okay, let's say you design and your deepest beam ended up being 600 millimeters. So what? It will be become 2.6 is the clear height. And eventually you have to really uh, figure that out. It is important to do that. Okay, that's one of the most important thing that you have to remember. You should be able to look at your plan and then provide external walls and internal walls at least in couple of cross sections so you understand where to go. This is the other thing you need to do is the typical loading. So let's agree on some figures. Self weight is we don't know, so we have to use trial section. Normally how we do a trial section is it's not a guessing, but it is an sort of educated guessing. For reinforced concrete beams, normally span to depth ratio of 20 is good enough. So if you are saying beam trial depth is equal to span to divided by 20, you know the span of the beam, let's say 6 meters, and then you know what that value is for the depth of the beam. Of course, the width of the beam can be decided as well. The depth of the beam can be estimated roughly. This is a trial section. This is required. Otherwise, you don't know the self weight of the member. Therefore, you cannot design. So you have to have a trial section. Reinforced concrete slabs, we normally use span upon 30. So let's say I have a 6-meter spanning slab. What would be my slab depth? It will be about 200 millimeters, isn't it? So 6 meters, 6,000 divided by um, the value of 30, which will be about 200 millimeter wall. Sorry, 200 meter depth for the slab. Flow finishes, I would say the load wise, you have to allow for flow finishes 0.3 kPa. I will allow here. It's a little bit on the higher side. Let's assume that in this residential buildings, and then you will be using very high quality porcelain tiles, which are a little bit heavy, and the leveling rod plus the glue plus the tile itself. Let's allow for about 0.35 kPa. 0.3 kPa for flow finishes. Ceilings and services, we normally allow for about 0.35, 0.25 to 0.35, but I have just given you a value. Unless you go and check with your design codes, you should be able to check this one, what you're using in Hong Kong. Partitions, because as I said, these are dry walls. Drywall construction really means well, we are not calculating it is length, it is height, and how like a line load, like we do it in brickwork, which are very heavy. What we normally do is we allow on the slab a uniformly distributed load to cater for partition walls. So all partition walls added together and then divided by the get the weight in kilonewtons and then divided by the total area of the floor is that value. So we normally recommended value we are using in Australia. I'm pretty sure Hong Kong will have a similar value, but you should say it is drywall construction will be used with the partitions, and then you will find somewhere around 1.5 kPa is good. Member live loads, that the other thing. What are the typical live loads in residential apartments is 2 kPa live loads as a uniformly distributed load. And also in Hong Kong, I think there's a 2 kilogram center span point load also has to be separately checked for that. I think that is we don't do it here in Australia, but I think still the residential general distributed load is 2 kPa. I'm pretty sure you should be able to calculate your live loads plus dead loads and load combinations and all that when it comes to this. So I'm giving you a few figures so that you flow framing and design validation sample using an error code here I have given. You can follow through this one a little bit. you are free to use your code, Hong Kong code, if you're familiar with. That's not a problem. So let's say now go and this is an example. I think the at the moment your main challenge is, okay, how are you going to design this flow slab? Which way to start, from where you start, that is the most critical part of your design. This is what called, without doing any numbers, you quickly try and see whether you can come up with a good proposition for your slab. Let's start with unit D. I will go to unit C soon after. Let's see what do we what we do here. Uh, Obviously, so in my case, if I look at this one, I see it this way. Let me just you follow what I am doing. Okay, to my eye, I can see that there is a slab. Our main focus must be how far the slab can span, where the slab can be supported by these huge concrete walls, which are very strong, load bearing walls. So for me, I would be seeing, okay, here we go. I have a situation like so. It's a slab, which is 1.85 plus 1.8 plus 1.2. So this is about 3, 4, 4.5. Let's say 5-meter slab. I know a lot of students, normally when it comes to this, a lot of students are really getting worried about, oh, someone, how can we do this? How can we do this? Right? So this is obvious questions because you haven't done some calculations per se. But let's for the time being keep those things where they are. We'll come back to in a minute. Okay, then I'm looking at a situation where what should I do with that part? Now, mind you guys, you see there is no support here. You remember that I said that if our flow height is 3.5, if our clear ceiling height is 2.7, and then you have 1.2 meters or so space between the ceiling height and then that. So basically, although you don't see, this concrete wall doesn't stop there. Now, if I look at this particular elevation, that's why I said it is very important for you to see this elevation here. It will be like that actually. It will be, I think I will use one straight line if I can. So this situation, if I'm looking from this side, I will be having something like this. That is the wall. That's the wall. At least 1.8 and 1 meters out of gap is there. But in the wall, that will be kind of an opening like that. There is a segment here above the door or whatever that opening is. Say in this place, you can see what I am doing here. I am what I am doing here is actually I'm trying to figure out what is this. Okay, there will be a sliding door here so that you can walk into the balcony. So that sliding door is 2.1 meters high. Overall height is 3.5. There's 1.2 meter wall section still keep continuing. So this is not a void. It is a void when you cut just above the floor plate. But if you go to the next level and then see down, and then you will see that there is a very healthy section. So this is the door. This is the door. So you have that. You have a similar thing here as well. So this is a continuous beam. You normally draw it in dotted lines. So that can be supported, this particular. And then I will see something quite uh, easy to do. Okay, what about if this is right? If I have something to support here, then um, then what? We are having a situation. We can have a beam. Of course, uh, this part will be like cantilever. That is no problem. But I think we can. It's a long length, and then we should be able to span this as a single span in that way. So that is very simple, straightforward situation. And then, of course, you have to have a beam here because otherwise this has nothing to support. So I might say I will be having a kind of a beam. Let's say I have a beam from here to here or there to there or whatever it is, because there is a beam here. You can so wall here. You can support your beam. Let's say I have a beam there. I have a beam there. So this part is sorted out, and then at the same time you will be having um, a slab which can be connected to this wall as well, and then you can either do a small beam here, so you can create a situation. This is a simply supported continuous. Oops. This slab also can be spanning this one way, and then this one can be spanning here, and then this horn, I think there's a wall here. If not, you can actually have external drywall construction here, and it can support this particular slab, because you have to have something there anyway. So this part of the balcony, of course, I can understand, but there may be something here. If not, you can easily have a drywall construction here. So that is the drywall component of it. So basically, what I am saying is that if you visualize this now, what is the the model look like here? So I will say that particular beam, slab is having a support here, having a support at the middle. You have to have a beam there, so though, and then there's that one here, and then that one will be this little two little segments um, coming to the edge. So you can have that being supported. Uh, if you wanted to go it this way, it's okay. Otherwise, what you can do is you can do a simply supported the beam. A small segment of the this slab comes and goes like that, because this is only 2.8 meters. You can deal with it easily. Okay, so the majority part is sorted out. So how about this situation? I can again go here, and then I can drop a beam here. So this is a beam, and then I will be having sorry, is a line diagram we want. I'll be having this also slab going that way. I also have this one is nicely going that way. So you need a beam here, of course. It could be about, this is 5 meters, this is nearly 3 meters, but there's 1,400 in D here, which means that this will be about 9 meters or less. Um, so you need a beam here, you need a beam here and a beam here, and then the rest will come into play. Nice and easy. Now, a lot of students may be worried about something like that. I don't think it is an issue at all. Just imagine this little triangular part. This triangular part is nicely resisted. It's a corner resisted by this wall, and then there will be definitely have something uh, here if it is based on the same argument here. There's a header beam like thing available in here, because people, if this is your main door, for an example, I don't know which one is your main door, but if this is your main door for argument's sake, then there will be a situation like that, isn't it? So there is a significantly strong beam, 1.5 meter spanning, which is very, very, very short span compared to the depth available, and then it wouldn't be a problem. Isn't it the same? And then if you look at, there will be a, this will be very similar to the elevation which I am talking here. There will be an opening also, and then there will be some other opening, but this does, what does that really mean? This part of your, this triangular part of your slab is pretty much supported uh, by these two. So the span is different, but you can consider the worst case scenario point. If I draw another section, this section I have drawn for the here, you have to actually draw these things to see uh, before worrying too much, I think, I guess. Um, I will see this one, this elevation. I use this one. This is pretty much a section through here. That is the model of that situation. This is the low part. I'm looking from 1, 2, 3, and a bit. That part is actually spanning in and out of the page. It is not even like a cantilever. Okay, so the direction of reinforcement is the other way around. So it is spanning between that and that. And then when it comes to here, I will draw another section like that. I will select a different line color, hopefully in purple. Now, if I am to look at the section through here, one corner, let's say the middle point, which is the worst case scenario, I'll be having a triangular corner, which will be very stiff, and then I'll see a model like that, two-dimensional model like that. That is that point, and then I come back, and then I see this. Uh, uh, this is this kind of one-way spanning slab situation. You can have a little beam identified very similar to this type of a beam going from there to there, and then let's say that is the one which is supporting it, and then you have another support, which is that the dotted line, this situation again happening here, because even if it is a sliding door coming to this balcony, this is 3.5 meters high, but only the sliding door is 2.1. There's a concrete part already in there, although you don't see it, that is there easily. So this is a little cantilevering part, and then this is the mid span, and this is the end span towards this point. So, and then if I go with a different color here, I'll go with red, and then I took a section section through here. What is that model look like in red? This one. So I'll draw it here. It will be having a good support there. Good support next. I'm traveling from here to there, right? And this blue color beam which we need to provide, that's the third, and then this is the fourth. So it is 1, 2, 3, one-way spanning slab. Now that is the beam arrangement in this case. Now if you want to then have a when you want to then have so this is one with a little cantilevering thing. This is a simply supported. So if you then look at if you then look at um analyzing this, you take a 1 meter wide strip of the slab, which is being supported by these beams, and then that encompasses your slab design. I'll go here and I'll select something like that. Now, if you wanted to analyze this, what you do is, oops, and then what you do is, I'll take about a, what's going on? Uh, okay. Um, so I'll take a 1 meter sort of segment of the beam. This is the sorry, slab. So this is the slab design I'm now looking at. All the beam designs are very simply supported beams basically. Um, they are very deep where the walls are. If you introduce this beam like this blue color one, which I am just drawing over, and in that beam you have to size it between span to depth ratios and then analyze it as a simply supported both ends, and then design this particular beam carrying the catchment areas and things like that. Now when you are how do you design the slab here? The slab is designed exactly like this. How do you design the slab here? It is like that. How do you design the blue color one? It is like that. In here, of course, this part of the slab is spanning other way around, in and out of the page. But therefore, actually, you don't have to necessarily worry about that. You can stop it from this one and then forget about that one. I go and blue, and then I said, because you can span this and then you continue and then you can do two little uh, slab sections. Now this is a cantilever slab. So in this situation, what I would do is I would again there will be a access here, isn't it? Sliding door to this balcony. So again, you will be having this particular column. It is exactly in this situation as well. Now, if I connect it so that you don't forget it, say this situation is here. This situation is here. So that is what you had to understand, right? This situation is there. Always there are these are not 100% gaps. They are having a part of the wall. Why you can't see it? Because this cross section is taken just a couple of meters above the floor, not below it. So these are all dotted lines. The yellow, the beams underneath are yellow lines. Um, and then this slab can be, of course, there will be a similar setting like that, right? So you have to try and see this happening first of all, um, and then you will be able to map out your beam. Now let's go to the other unit. Um, okay, this is the C situation. We will have this. We will have um similar consideration. So that if I look at C1 again, um, one of the things which you can do is actually you can. This is only 5.7 meters. This is 5.7 meters, and this end is free at the moment. Okay. Now I'm just asking, can't we span this one in this direction? You can. and then you have to see what is around here. There may be a slab, because this is where you are entering to the house, um, or somewhere. Just have a look. If not, what you have to do is to have a line which is a blue color or so. um, you identify a small beam which is going from there to there. I will not get I will get rid of that actually. I will use the span in that direction. This one can also design as a two-way spanning slab, and with a little cantilever. So if I do this cross section, what is the model look like? Starting from here, there's a little cantilevering part kind of a thing, and then you have this big wall that is where the this beam comes, and then you can have right at the end. Sorry, this is a simple model with this cantilever. The backspan is so much when it is deflecting like this. I'll use it in a different color. This is going to deflect like so, and then like that. Now, if you deflect like that, sometimes you'll find this tip is actually trying to go up, because backspan is so large, and then therefore this tiny little segment here, maybe 500 millimeters, or at best a meter, then you can see that this cantilever is not struggling at all, which is exactly the same situation you can do. But in this case, I think you have to do uh, a one-way span slab. But I will give you another alternative before I go from here. Um, Go back again. Now, one other option available to you is you see this slab. I use blue color here, um, as I originally suggested, one-way spanning slab, one-way spanning slab. Um, these are one-way spanning slabs. Of course, you will be having that yellow color situation here exactly the same. So you can go one-way spanning slabs, but this part is a little bit dodgy. Um, I would suggest that in this case, you have a couple of options available to you. One thing is that getting a little bit of an edge beam to support this very small cantilever. I suspect if you go and look at the plan properly, there will be a possibility that there's some member. If not, what you can do is, as I previously said, you can actually propose an external drywall construction, and then having identify a support. But I think the easiest is, because that is the case for the slab, we will do is you can get a 1 meter segment of a slab just going from there to there, which is quite easily be done, which will be applicable to all this section. One-way spanning slab, and then these are reactions. You don't have to design any of these. But this particular little cantilevering part can be a part of detailing. Will work this out, and then try and you can have some form of stiffening happening here. But have a look at that carefully. But you can shape it up. So that is one of the things. And then how about this situation? In this situation also, that you have because this is a balcony, so there will be this particular one will some or the other come and then connect here above uh, above the below this other slab, and then you can utilize that as well if necessary. uh, in this option, of course, one of the better ways to do is to try and have a I'll go to a blue color or something like that. You can run, oh dear, uh, yeah. You can run, I guess, a beam from there to there, and then you can try and work out a slab. Sorry, again, one-way spanning slab this way. So, and this is a little bit of a triangular kind of a situation, but there is a very large section, so you can assume that it can easily be designed to span that way. So if I am to take a really large slab strip, 1 meter wide slab strip to design, then this is how that model will look like. I'll start from here. So, oops, I have to go to yellow. So I'll start here and then keep going like so. This is the worst case scenario probably. So what is it look like if I take a section through here? If I take a section through here, oops, I want only one line. I'm almost there, guys. When I finish this one, it should be okay. So if you look at this one, what can you see? You can see a beam, long beam, and then you have at one point that wall. This is that wall. And then you will be having this wall there, support. And then you will see that wall will be supporting. You will be seeing this one. I'll draw it in blue color so you know that is the beam we are talking about. So I'll put this blue color support, that is the new beam, which is not a wall, which is a long beam that you of course you have to do. And then in the triangular component that you will be having. So first of all, guys, all these little openings you can connect with dotted lines. Okay, so dotted lines. All these, there will be, because these are walls going full over the full height of the building. You can't just stop like that. There will be an opening to access these corridors and verandas and things like that, cantilevering parts then, and that is how it works. So that will cover a fair bit. But then there's a little corner here. So this slab can serve until here, and this part will have to be, of course, it should be, you have to consider that as spanning that way, and then you have to consider that as spanning that way. Right? So it is just a matter of doing that. Span to depth ratios were given for beams and slabs. You can do with a trial section. You can use space gas or ETABS to entire model this thing, or you can do it using simple two-dimensional models like that, if you wish. Okay. I think that brings us to sharp 3 hours continuous. So I'll sign off here and wish you all the best in your design. It's and hopefully you can, with this little tips, that you should be able to really figure out what is happening. There's one more thing probably you may like to do here. Again, this is a classical cantilevering thing, because this one is going in this direction, so this is one way. But if for this, one of the things that you can do is you can thicken this one, and the other thing is that you can consider that, and mind you, you have that deeper beam here as well, and then you will be having a fairly uh, 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 I'll just quickly do that for you. So you will be having a little beam here as well, mind you, very similar to these areas. And then, of course, this will be, if I were you, I would be really putting about 2 H beams here, and those 2 H beams, and so I will make uh, I'll make this particular cantilever part not cantilevering, but actually simply supported through these 2 beams. And then, of course, these 2 beams, if you can do within the same depth of the slabs, that would be fine. So in that situation, inside the slab, the same slab depth, but you will be having extra reinforcements there. That is another way to do it. So you will be having reinforcements in top and bottom within the slab depth. So if you make this slab thickness to be about 400 millimeters, because it's a cantilevering segment, you should be able to detail. Your reinforcements will be uh, uh, coming. So that is a little bit of maybe. So this area you have to do it slightly differently. Okay, so this one you will see act like, um, if I draw it in blue color line, I think that would be better. It is the slab. There's a little beam underneath. You can even overturn that beam. This is one option for those H beams. And the other option for those H beams is the turning it other way around. So this particular H beam, which is being supported off the slab, can act like the balustrade, so that so this is where you are. Oops. This is where you are sitting. So it is inverted beam. The beam has actually turned upside, and then that will provide like a balustrade for that particular balcony. And then that will be extending, these beams will be a little bit extending towards and then having a connection here. So you can do detailing into that. Some reinforcements will be going through the beam, through the slab. Slab thickness can be increased a little bit in that area so that you can accommodate that. If I were to, you ask how far that reinforcements must go, Saman, I would say if I take a different color, red color, I would use somewhere 2-to-1 ratio. This is 1-to-3 ratio. So I would get reinforcements further